Welcome to Skill Session. Today we're going to talk about the most popular tool in the world when it comes to collaborating over code. So this is the de facto standard when it comes to code, version control, collaboration, all those kinds of things. We are of course talking about Git and GitHub. Now Git and GitHub are two different things. Git is the system that we work with, or the application if you will, whereas GitHub is just one of many places where you can put your code, or the server for your code, for hosting your code, if you will. Of course, GitHub builds certain features on top of Git, but you can see it that way. So it doesn't matter if you're in a project group in a school environment, if you're starting out in an IT job, or if you're working with your own code on your own computer just to get started. Git and GitHub is the way to go. There's no two ways about it. We're going to look at this from a conceptual view, so figure out what's it all about. We're going to look at it from a technical point of view. So we're going to test it. We're going to actually set it up. And we're going to look at it from a collaborative point of view, because I often see that's what's missing in these kinds of guides is no one's really talking about how do we make this work for us when we work together as a team. Now, the first thing you need to know about Git is the repository. When you work with code, all of that code is saved somewhere. Normally, you just save it on your own hard drive. But when you need to collaborate, you need to save it somewhere that you can all access it, somewhere online in GitHub in your repository. So when you have multiple different projects, you'll have multiple different repositories, and each repository will consist of its own code, its own set of collaborators, and so on and so forth. But this repository is actually placed in two different places. You have it on the server, your GitHub server, and you have it locally on your own computer. So as soon as you clone the repository from the server, you have it on your own computer as well. So that means that when you're working with something where you have multiple different versions, multiple different branches, and multiple commits, and we'll get into all of that in a moment, all of that is stored on your own computer. So if you're sitting offline somewhere and you want to go back to the version that you had yesterday or see what's on another branch, you can do that. Of course, it's only updated when you update it from the remote, and the remote in this instance is GitHub. And of course, your own changes will only be sent to the remote, and you'll only get the changes from the remote whenever you ask for that. But it's just important to understand that everything is actually contained on your computer. So if there's 10 people on the same team, then all of the files in the repository on the remote is also saved locally on your computer. So even if someone goes out and deletes the project, deletes the account that the project is hosted on, you can still recover the project because every single person working on it has everything lying on their own computer. How awesome is that? So when you have the repository, you need to figure out what part of that repository it is that you want to work with. You have a bunch of code, but you have it in multiple versions because you've done multiple commits. And when I say commit, you can think of it as saving. So every time you save your changes, you make a new commit. And you can go back in time to a previous point in time where you made a commit. And this commit is a save across files. So you can change something in 10 different documents, then make your commit, and then go ahead and do some more changes. And you'll name each of these commits so you can come back to them later on. But you can do more than that. You can also branch it out. So if you want to try something that goes in one direction, something that goes in another direction, and something that goes in a third direction, you can try it in 3 different branches, and you can just jump back and forth between these approaches as you wish. And this is often the way that you work with code when you want to collaborate, is each of you have a task and you create a branch that's named after that task. That's called the feature branch. And then you make your changes, and when you're done with those changes, you get someone to review it, and then you get it into the main branch. We do that normally through what's called a pull request. And the pull request is just a way to tell the system and to tell all your collaborators that this feature is done. I want to merge it into the main branch. So if someone could please review it, then that would be great. Now, one of the great parts about a pull request is you can set up a pipeline behind it. We're not going to go into that in this video, but you can set up a pipeline behind it. So that's where you're going to check the code quality. You're going to run your unit tests. You can do all of these things just to make sure that the code has the best possible quality before a person has to look at it. If your own tests or automated systems can say that there's a problem with the code, then there's no reason to waste another person's time on it. Then you might as well fix those errors before you go ahead with the pull request. That also means that you have a really good chance of avoiding putting code into the main branch that doesn't work well. So when we look at these diagrams, we have a main branch that starts from the bottom, and we can see that we branch out to one side or the other, but we always end up merging back into the middle. Now we can do something called git flow, and you might want to look that up. I'm probably going to do a video on it in the future. But that's how you control it when you have multiple different versions that you're maintaining at the same time. But that goes beyond the scope of this video. That's primarily for beginners. So let's take a look at the technical stuff. Let's create an account. Let's create a repository. Let's clone that repository to our own computer. Let's make a branch and let's make a document. So I'm going to sign up now. Sign up. Let continue. And I'll make my username skill session. And because I know everything about galaxies, I was able to verify that I'm not a robot. Just like Mark Zuckerberg. He's not a robot either. Did you know? And GitHub just sent me the code. And bam, we're in. And we're just looking for the free account. Okay, so we have an account. Let's create a repository. You can think of that as a project. And I have a couple of projects that I want to put here. One of them is my database admin. So DB admin, accessing your database without a full desktop application. And I'll make it public now, but I could make it private so that I could work with my team on this code without it being visible to the world. But this is something that I want to share with all you guys. I'll create the repository, and here we go. Now there's a button here that says set up in desktop. And if you want to do that, then you need to first download and install GitHub Desktop. But what you need is really just this address right here. That's what you need to clone. You can click out here to copy. Now you can open GitHub Desktop. GitHub Desktop, you can go there, you can download it. And once it's open, I can go up here into preferences and I can say sign in. I'll continue with the browser because I'm already logged in the browser. Authorize desktop and open the app. There we go. And now I'm logged in. Now it's remembering a couple of things here because I had it installed already. But I can go up here and say file, clone, repository. And we'll go over here under URL because we just copied the URL from the repository that we just made. I'll hit clone and boom. Now we have the repository right here on our computers. And we can click here to show it in Finder. And we can click here to open up the whole folder inside Visual Studio Code. So let's do that. Do I trust the authors? I'm the author. No, I don't. Of course I do. So now I can go up here and I can say new file, welcome.txt, because I don't care about programming languages right now. We just want to see how Git and GitHub works. Welcome to this awesome repository. So if I go back to GitHub Desktop, I can see there's a new file here. That's what the green symbol represents. And I can see all the things that were added to this, and that means I can now make a commit. And since this is the first commit, I'll say first commit, and I'll commit that to the main branch. Now, this only exists on my own local computer, so I need to publish the branch in order to make it visible for anyone else, and then I need to say fetch origin. Now, the great thing about GitHub Desktop is it has this magic button up here that almost always knows exactly what it is you want to do, so you don't even have to think about what your next action should be. This also means I can now jump over into the browser and I can see here, if I click code, that now my code exists in here. I can even click on it and see it here. I can click the blame button and I can see who wrote the different lines of code and what commit it came from. But generally, I don't want to merge things directly into the main branch. I want to work in different branches. But now that I have a main branch with a little bit something on it, let's go over here and create a new branch. Branch, new branch. And I'm gonna call this the monkey branch. So create branch, monkey. I'll publish it, sure, why not? But now that I'm on the monkey branch, I want to make a change here. So I'll want to replace all of this with ooh, ooh, ah, ah, because that's what monkeys say and that's what monkeys do. Give me bananas. So I'll save this. And if I go back, this change, you can see what was removed. You can see what was added, and there's this yellow icon saying that something was changed in this file. By the way, I don't think we're going to see a deleted file, but that would leave it red with a minus in it. So, monkey patch is going to be my commit, and I'll push it to the origin. So this change has been made, and it's asking me if I want to create a pull request. I don't want that yet, because right now I want to compare what does it look like on my main branch. And see here, when I change, GitHub Desktop actually changed with me. So I can see that these are all different. But at the same time as the monkey is working over on that branch, let's create one more branch because the monkey's not the only ones working on this, right? I'm gonna create the cat branch. I'll publish it. And now I'll jump in here and I'll say meow. Meow, meow. Okay, perfect. And we can see here all the changes that I made. And normally when you do these commit messages, please write something that makes sense. But since the code doesn't make any sense, it's kind of difficult, but please do that because otherwise you'll have no chance to figure out what it was that you actually did when you need to go back to a version. But I'll call this meow. I'll commit it to cat, push it to origin, and I'll create a pull request. This is going to open up the browser. Create the pull request. Now, I'm the only person in this repository, so there's nothing here, but you can see all these rules I actually tested, like we talked about before. And we can set up multiple rules if we want to. We can add rules right here, but that's a bit more advanced. Right now, I actually just want to merge the pull request. Confirm the merge. And I might as well delete the branch, otherwise we're going to have 1,000 branches lying around once we are done with this project, right? So that's great. Meow is now merged. And that whole welcome thing is gone. So let's jump over into our main branch and we can see that it's actually still the same old stuff that it says down here because we don't know about the new changes. So pull origin. Oh, and now the main branch looks different. But I can go over to my monkey branch. This looks like it always did. You know, welcome and repository. This actually comes from that original file and we just changed something. We can even see the blue line out here saying what it was that we changed from the branch that we branched out from, the main branch. But you know what? I'm done as well. I'm just going to create a pull request from the monkey because I want my monkey code to be part of the main branch as well. Monkey patch. But now it says can't automatically merge. I'll create the pull request here. And when you have a pull request, by the way, you can go over here and click on commits to see the commits that made up all of this. And you can say files changed. And you can see what was changed in the files in this pull request. And you should do this and then review the change and say approve or comment or whatever before you save your review. But if we go over here into conversation, there's a conflict that must be resolved. Git couldn't figure it out because it was trying to merge the ooh-ahs into the middle of the welcome message, but the welcome message that it's trying to put it into doesn't exist anymore. It just says meow meow. So let's click on resolve conflicts. So really all it's saying right now is, well, there's a couple of things here. I think meow needs to come first and last, but it seems like there's something else that you want to put in between. Right now, it's actually writing out two versions, and this is what it does whenever there's a merge conflict. It tells you two things that you can choose from or that you might want to switch orders on. So the first version goes from these arrows and the name of the branch it came from and down to all of these equal signs. And then the other version comes from these equal signs and down to all these arrows pointing the other way and the name of the branch you're trying to merge into. So in this case, I can just delete all of this, delete all of that, and now I've actually resolved it, so I'll mark it as resolved. And I'll click commit merge. So now that I get back here, it says verified. It still says that there's a conflict. Let's click on that real quick. And now it can see that we fixed the problem, and now we're able to merge the pull request. Confirm merge. So that's all great. We made a couple of changes, we had a conflict, and we solved it. But how do we avoid these conflicts in the future? First of all, when you make your changes to your branch before you create the pull request. So on my giraffe branch here, I'm going to change bananas to leaves because I want to eat leaves. I can see the change here. And before I create the pull request, I can go up into branch and say merge into current branch. I can select the main branch and I can create a merge commit. Now, there are no changes to the main branch, so I can't do this. But if something was merged into it, I could actually do that. And that means I could handle the merge conflict here on my own branch before I created the pull request. But the most important thing to keep in mind here to avoid merge conflicts is this. So make sure your branches live for as short a period of time as possible. Just read and understand your task, look through the code, and then last minute, just when you're ready to start coding, that's when you create your branch, you build your code, and then you create that pull request so you can delete the branch again. The fewer branches that exist at the same time, the better. Because if you build the feature over too much time, then too many other changes are going to come in and you're just going to have one merge conflict after the other. You don't want that. So make it a goal to have your branches live for as short as possible. The next thing you want to do is you want to name your branches after your features. So if you're working with a management tool like Jira, Trello, or the boards that you have inside of GitHub, then all of your tasks are going to get a name. Make that name the name of your branch so you can see what you're working with. And if you work with Jira, you can actually integrate GitHub into Jira so that Jira can recognize the branches and you can look at your task and click on the GitHub part and the code changes are going to pop up on the screen so you can see the code that's being changed right next to the task directly inside of Jira. It's really powerful. And always make pull requests so that someone else has a chance to review your code before you merge it in. You can create a file named Codeowners inside of GitHub, inside your Git repository, where you name some people who own the code. So if you have a specific few people that you always want to review your code, that's the way to set that up. You can also set a rule up just saying that code can only be merged if you have at least one approved review of your pull request. So you can do different things like that to avoid people merging directly into the main branch. Committing directly to the main branch is always a bad idea. And the last thing that I want to mention in this video is going to be Git Ignore. So you're going to have some files once in a while that you don't want to update for everyone. A really good example of that is when you're working with a database, you'll want the credentials for your own database on your own computer. And those credentials are going to be different on every account for every user who has their own computer with their own database set up. You should have a file in your code that only contains the credentials for your database. And then you can add that file to Git Ignore, and then it won't be part of your pull requests. You can just have your local username and password for your local database, and it won't be pushed with your pull request when you change it. You can also use this for larger media files that you don't need everyone to download. That's going to be it for today's skill session. See you next time.